Hi everyone, welcome back to my channel. So the season for long e-bike rides is fast approaching, or bike rides, long bike rides for that matter. And in preparation for that, I have this second motor. If you have seen my last videos on the topic of the Bosch e-bike system, you must have seen that I have this second motor, which I got from a cousin of mine, and it had a problem. Basically, the problem with it is it shows code error 503 on the screen, which is normally something to do with the speed sensor, basically the sensor that senses the magnet on the wheel. Long story short, it does not work. It just doesn't detect the sensor, even though we've tried multiple sensors with it, sensors which I know that they work. So for all purposes and intents, it is basically a braked motor. Luckily, I have known about this for a while. I've seen it on this wonderful forum or website, which is called the Endless Sphere, which is something that people have done way back in 2018, 2017, stuff like that, 2020. And I'm talking about multiple posts by multiple people. I don't remember the names. They had done this exact same modification. So if you have a Bosch motor that shows up an error code that is not repairable, because sadly, yes, there are some problems. The 503, after some research, I've noticed that it was a recurring problem, at least with the Gen 2 motors. And especially when it occurs after the warranty period, there's nothing you can do basically except pay for a new motor. But not all hope is lost, because thankfully there's such a thing as a Vesc, an open source fully programmable controller, which is basically what this is based upon. This is a model by MakerBase MKS, and this is the 6100 HP model. Basically, you can change all of the settings, and even for people that have programming skills, you can do a lot of magical stuff, and it already does a lot of stuff because people have been working on this for a long time, and there's a lot of material, resource materials on the programming, the all the functions, all the projects people have done, either on GitHub or on MakerBase's own website, or the FlipSky is also a very famous Vesc manufacturer, and there's a lot of other models as well. I don't know all of them. I basically just this is my first Vesc. It is quite simple to the wiring is quite simple, as you can see. Excuse the mess. I did this just for testing purposes. So as you can see, the three-phase wires are not color-coded, so you can connect them however you like. The battery pluses and minuses are here, and there are some other. Let me show you on the it's gonna be much more clearer. So there you go. You have USB Type C, PPM, which is something to do with the if you want to connect a remote control for example, for e-foil surfboards or skateboards in general. Then there's the CAN bus connection, which is basically when you want to connect two controllers. For skateboards also, they are usually equipped with two motors in two wheels, and some controllers do have two phase connections, meaning that they have ABC and let's say UVW, so two outs of three phases. And if you don't have that, you can use two of the same controller and connect them over the CAN bus. There's a master controller and there's a slave controller, from my understanding. And you connect your throttle, for example, to the master controller, and whatever it does, the second controller does automatically or at the same time. Next, we have SWD, which I don't quite understand what it does. There's the CALM. this is basically where you have your analog to digital converters, which in this exact model we have 3 ADC 1, 2 and 3. We have some other connections, TX, RX and ground 3.3 volts and 5 volts. This is, for example, where you're gonna connect the controller, which is what I have done here. You basically connect to the 3.3 volts ground and ADC 1, 2 or 3, whichever you want to use. And lastly, we have the Hall connection connection. With this controller, with this Vesc at least, it has support for the AS5047 chip, which is a magnetic angle encoder, which I have actually bought, which I have right here. I did buy this just in case with the controller itself, because in case it wasn't able to run the motor sensorless, which is what I ended up doing, because it can. So this is the chip. This is the AS5047, which is basically a detector which is inside this chip. And if you want to use it, basically this is a this motor is already equipped with this kind of magnet, because it requires a special magnet, and you have to position it over it with 1 millimeter to 3 from my understanding. In any case, it detects the exact position of the motor. That way, when you start the motor, it knows exactly which phase shift, I think, to apply exactly to the motor, so that it will have maximum torque at start. In any case, you can connect this little module according to this scheme that you have right here, because that's what these pins are. If you can notice, there's 5, 3.3, ground, CSN. We have clock, MOSI, MISO, and ground again. Those are technical terms. I don't exactly know what everything is, but the connection is quite straightforward. You just connect according to this scheme, and if you actually have Hall sensor in the motor, you just connect it to the Hall sensor, 5 volts I think, temperature sensor if you have one, then 1, 2, 3 and ground. In any case, and there's also the scheme for the ABI connection, which I don't know what it is either. I also think it is another type of magnetic angle encoder. Although on the other hand, you can also use the original magnetic angle encoder, which is this is the Bosch one, and it is based. I will actually put a picture of this chip, because it is not very recognizable. I couldn't actually see with my bare eye until I used a digital microscope, and I will show the picture of the chip. I forgot the name, and this is basically, after you look at the data sheet, it is not very complex, and basically you just have plus and minus to power the chip, and you have 2 output signals, the cosine signal and the sine signal, and those you gonna connect on here. So the 2 outputs are going to be connected on ADC 1, 2 or 3. I will not do that for now, because there is actually a very detailed explanation by Benjamin Vidder, the original creator of the Vesc, on YouTube. You can look it up, of course. I will try to put a link in the video description. So I think that this is very doable and quite easy to incorporate, because it already has the it already has the place, because when this is positioned inside the motor, this is over the shaft, and this goes, I think, just like this. Yeah, it has its place, and it's already positioned, which is not quite the difficult task of if I had to use this one, I could grind a little bit of this tab and fix it with some new screws, according to, you know, when you find the position where it works perfectly. In any case, that's for the Vesc. And the only thing that Benjamin Vedder said on that video that I watched on the using the cosine sine encoder is that apparently, I don't know, this is the video dates to some 1 year ago. So according to him, I don't know if you know, someone has come with the new programming to avoid this, but basically what he said is that when you connect the cosine sine encoder to the ADC 1 or 2, it's not like you have the ADC 3 free to use, for example, with your throttle, because you're gonna have to you know, on the programming, because you can connect the Vesc to a PC. The error that I have done is not buying, which I will do in the future, is not buying the Bluetooth module for the controller, because it simplifies life very, you know, it simplifies life a lot. You can just use an app on your phone and program the Vesc as you will, and also most importantly on the go. Because right now I only I have to have my PC ready to connect to it if I want to change anything on the controller. Going back to what I was saying, apparently you're gonna have to run a different app for the ADCs to accept the sine cosine signal, and it will no longer work with the throttle control. And also, speaking of the ADC ports, as you can see, for now, just for convenience and for testing purposes, I'm running the motor in with throttle. I'm gonna try it with the throttle, but you can also try it. You can also use it actually with the original. What is it called? With the original torque sensor, which is included already in here. This is actually the connector which goes to it. I have taken off. I've tested it with the bike powered on, and if you want to use it, this is also a project which I found on Endless Sphere, which is someone which had worked on a similar project like this, and was successful in using the original torque sensor to command the motor. And you know, that is very good and way more perfect than using the throttle, because you always have to use your hand, and sometimes, or at least for me, on long distances. For example, I don't feel saddle sores, but I feel, you know, I feel my thumb hurts, you know. So this would be perfect, and I will try to use this in the future. But if you want to use it yourself, I have found the pins, and the way it works basically is that it has the ground minus basically 5 volts plus, and it has an output signal of 2.474 volts at rest, and depending on you know, which way you turn the wheels, of course it's always gonna be on one way when you pedal, and when you back pedal, it will not, of course it will not, the motor will not go backwards, but the movement is still actually sensed by the sensor. In any case, this, according to the guy who posted the article on Endless Sphere, it's actually you have to make some adjustments in the software of the Vesc in order for this to work, and it has to the throttle curves has to be reversed, or at least voltages have to be reversed, you know, instead of the way it works basically is when you pedal, and the harder you pedal, the lower this voltage goes down. So it will go to 1.2 or something like that. I don't remember the exact details. In any case, this sensor, where is it? Yeah, this sensor basically has three pins, as you can see. So 5 volts plus in the output signal, and if you want to use them or try this yourself, of course you just have to open up your motor with your motor connected to your bike, so you power it on and then you do your measurements. But if you just want to, for me to show you, So as you can see, this where is it again? This connector is connected like this. Yeah, so it's connected like this, and that's what I drew on that little card. So it's these top 3 pins, okay, and that's what they are. So as you can see on this lower drawing, it's not perfect, but you can see the number 1 pin is the one at the top right here. The second is just the one below it, and the third is the one below that. So that's the first one is the output signal, which 2.474, and it goes down. The ground signal minus, and the 5-volt signal. And what you're gonna have to do is just connect the ground to ground on the Vesc, the 5-volt to 5 volts right here on the COM port. And you connect the output signal to ADC 1, 2, or 3, whichever you want to use. So you connect it to one of the ADCs. You do some programming, which is not too hard. I don't mean programming as in writing code. You just have it has a GUI, a graphical user interface, which simplifies things a lot. And it is kind of difficult to navigate at first, but you live, you learn. And after programming it, it works perfectly, apparently, at least according to him. That's something I'm gonna try in the future. Right now, the biggest dilemma that I have is that, let me just show you if I can. So I have my bike right here, and the biggest dilemma that I have is that it uses this rear wheel hub, which is the Nuvenci, or formerly known as Nuvenci. I think now they go by Inviolo. Inviolo automatic, which basically has, excuse the voice of my laptop. Wow. I need to change those fans soon. Let's just wait for it to shut up. Finally. As I was saying, so this has the Inviolo automatic rear, what do you call it? It's a gear changing mechanism. The sad thing, the worst part about it is that, according to my research, it only works with the Bosch system, and they have newer models which have Bluetooth. In that case, of course, you can run it with the selector, which connects to it via Bluetooth. Not in this case, so I will try to take the controller out of there, and yeah, so I will try to take this original controller, because it also needs to have the programming to work with the Inviolo hub. The programming, sadly, is done by a dealer. I can't do it, I can't do it at home. And yeah, my biggest dilemma now is that I'm gonna try to take out this good controller from this good motor, and put it on the second motor, run the phase wires outside, which I've already made a hole, which I'm gonna show you, and then try to make this work. Hopefully it will work, because it's gonna have to have the phase connections detached. My hope is that when I put it on off, as in when I'm not on touring mode, or sports mode, or turbo mode, I hope that it will still function to at least hopefully eventually run the lights. Hopefully, I wish for it to run this hub, because there's no other way to run it except for having it connected to the Bosch controller. As I was saying, I'm gonna run. I've already made the hole, so it comes out from here, and from here I have these CT60 connectors. I think they are called the CT60, I don't know, MT60. So these MT60 connectors, which look like this. Basically a three-pronged connection with male and female. And as you can see, the running of the motor is not like perfect when you run it sensorless, because that's the role of the Hall sensors or the encoder or the cosine sine encoder. It's the smoothness of running, but I think it will not be a problem because it's only a problem at the start. If you can notice, with very low throttle input, it struggles a little bit at first, but if you actually just push it all the way, the magnetic fields that are generated are quite strong to push the motor into motion. And of course you have to program it to run this direction or that direction. Of course this motor has a internal freewheel, so even if you run it the other way it will not cause damage, hopefully. I think in any case, I think this is the direction it will have to go for it to this is the direction it runs normally. I think I have to test it first, but I've taken a look at the gears and it made sense for me, unless I've made a mistake. So there's a 50-50 chance of that. And also I've also modified the throttle curve on this controller, on this throttle. I'm eventually gonna use this one and I have to program it with it. And I've made it to my preference. I don't like, because the way it was originally, as soon as you push the throttle it goes way into a higher speed. And I've also, because when you first connect the Vesc, you go through a very easy tutorial, let's call it, where the Vesc using your the software on the computer tests your motor. Thanks to that to that post I've told you about on endless sphere, I found out there was a very useful information on there. I found out that this exact motor is an 18-pole motor. So because the default setting is a 4-pole motor, it will work, but when you actually pass the setting stage, when you try to use it, it doesn't quite work well, because this has 18 poles, and when you run it with only 4, you have a lot of gaps between when the torque is generated and the next phase. In any case, after setting up the motor, it also tells you some information. For example, the resistance of the windings on the motor, the maximum amperage you can run through it. For example, this one, it showed a maximum amperage of 40 point something amps, and I have actually limited it down to 35 or something like that, or 30 even, I think. And you can also go overboard if you want. If you want even more performance from this motor, you can add 2, 3, or even 5 amps without actually burning the motor, except when you run it for a long time. And you can play with that as you will, and configure the motor to your liking. So as you can see, the principle of working of connection is very simple. So not gonna bore you with all the details, because it's only gonna be wiring and trying to make it a little neat. After that I will tell you about the result. Also, something that I forgot to mention about the Vesc is that you can use it with any type of battery voltage you want, up to 60 volts. That's what actually the 60-100 and the model number means. So up to 60 volts, I think that would correspond to basically 14 or 15S batteries, and up to 100 amps. And of course, the higher the voltage, it's always going to be better, because you're going to be able to run lower amps for the same output, basically. And if you actually calculate that, 60 times 100, which gives you 6,000 watts, which is quite a lot. It's basically almost 6 horsepower, which is, for an e-bike, is quite a lot. Of course, I'm not using the full extent of capabilities of this controller, of course. Like I already mentioned, I've limited even the phase amps. I've lowered them a little, and I've also limited the amps coming from the battery, which I've already done actually. Thanks to, right now I'm using a 36-volt battery, which already has the ant controller, the ant BMS, which also is programmable, and you can limit the current output. But nonetheless, you can even use this Vesc with a straight, without a BMS, with the battery without a BMS, if you want. Of course, it's not gonna be able to tell if one of the cells goes below the recommended voltage, but it's gonna stop. You can program it to stop at a certain voltage. For example, for the 36-volt batteries, it is gonna stop automatically at 29 volts. As you noticed, I'm gonna be using a second battery to power the bike, the motor alone, and the original Bosch battery is only gonna be powering the rear wheel hub and the lights if you light them. So yeah, for long distance e-biking, I kind of lose half a kilowatt of power, but on the other hand, I always have half a kilowatt of power to run the lights, the rear wheel hub, and charging my phone and stuff like that. The second battery that I have is already good enough for the distances that I do. I'm actually planning to do a long distance trip with this e-bike, and in that case, I'm gonna be trying to equip it with 3 kilowatts of battery. So that's I have actually 3 of these batteries that I'm using. 2 of them I'm not using at the moment. I just have them sitting. Just sitting. I haven't used them in a while, but I did buy them for that purpose. I'm gonna connect them the same way that I did with the, if you have seen the Bosch battery hack video, using Schottky diodes. So they're gonna be discharged at the same rate at the same time because they are similar capacities. And like I said, I will always have the Bosch battery in the frame as a backup. Alright everyone, so I'm finally done with the wiring, and I was very lucky that I was able to fit everything inside the frame itself. I did have to again, excuse the mess. I did have to take out this adapter thingy, which is what holds the battery in place, and those are the 2 holes where it holds normally using this bracket. So I've done the wiring, I haven't finished up, and the most important thing is that the bike works. So this is something I forgot to mention in the beginning of the video, and this is something I had. This is error code 504. This is something I had because I was using the speedbox, which is basically it's an adapter which you connect to the motor and to the speed sensor, and that way you can activate it using this button, the walk assist. When you hold the walk assist, you activate it, and it allows you to go past the top speed of 25 kilometers an hour, which is what we have in Europe. I was aware of this error code before I had it for the first time. Then it happened to me. What happens is that your bike goes into what is called a limp mode. After that, it doesn't assist you. The motor stops working, although the bike system itself stays on, but no assistance. But the first time it happened to me, luckily, I think this is just a bug in the system because of the integration of the Inviolo system. So after much messing around with it, I was actually in the middle of a ride. So normally I didn't want to push this bike because it happened to me once. I was out of battery once, and I had to do something like 20 kilometers. And it was the worst 20 kilometers I've ever done in my life. It was like It's very, very heavy because the inviolus system itself is not very efficient. It's not very efficient. The chain in the cassette system is much more efficient in delivering the your output to the wheel, and yeah, that was not a good experience. Anyway, the first time it happened, luckily, after much messing around with it, I found out that when I put, because you can either choose a cadence system with the Novinci rear hub. You basically set up your cadence, and you pedal either fast or slow if you want. The motor just keeps up, and it changes gears automatically. But on the other hand, you can push on the I button in hold, and you can get into a virtual gears. So you have the first gear, second gear, etc., up to the ninth gear. When I have it in the ninth gear, which is the heaviest, luckily it starts to help you a little. But the this is actually the power bar, which shows how much the motor is helping you. So when it's full, it's on max. In the when it's in limp mode, it basically helps you up to this thing, the first thing, or sometimes the second thing at start. So with the ninth gear, you know, it wasn't funny to drive because you were always stuck in the heaviest gear, but at least it helped you. But it was also limited to 18 kilometers an hour, so that was not fun either. Anyway, I had the error code for the second time, for a third time, and on the fourth time it didn't want to go, because each time it happened, it normally takes about an hour and a half, and the error code goes away, and you can even reuse the speedbox. And of course, after reusing it, it happens again. It doesn't always happen. That's what something I don't understand, because I've done the first some 1,000 kilometers and it didn't happen. It happened for the first time, and within like 2 months I was already it already happened the fourth time, and it was stuck, and this was months ago. Which was actually one of the motivations that I had to buy the Vesc and power everything with it, at least the motor. As you've already seen in the video, I've taken out the cables out of the motor, or out of a hole, and I've put some glue inside to waterproof it. I will put some wax also to just to make sure, but after I'm done testing it and everything, because I haven't ridden it yet. And I was lucky to be able to pass everything through the frame itself, and I will show you in an instant. But the most important thing was that the gear system works, and also the lighting still works. So yeah. This modification is now redundant because I'm not keeping the original Bosch system, although I would still have to carry this battery all the time. And yeah, the second battery I usually put right here on the under the frame, and it will be connected like this with this cable. So to show you the inside. Okay. So as you can see, after taking out the battery, I did have to move this adapter just a little bit, and put it a little bit to the right, and I was able to pass these. These are the phase cables. I've just doubled them up to make them, you know, less resistance, and I was able to run them right here. And of course, if you have paid attention, you would have already noticed that I have put the throttle right here. I run the cable, and I've run it through the frame from here. And I was also very lucky with this controller, because I was considering buying a different model which had the outer case, and I finally went with this one because it was you know, it was better than the other one. It had higher amperage, higher voltage, And the form factor was also, I was very lucky with that. I didn't actually measure anything. I was thinking of putting it. I knew that there was a little bit of space in here, but I never got in there to see how it is. But luckily it does go all the way through here. So yeah, that makes the bike a little bit more neat. And yeah, as you can see, this I went actually to the hardware store the other day, and I didn't find the right connectors that I wanted to solder this. But then I thought I would also need bolts in nuts to tighten them together, and bus bars and stuff like that. So I finally went just with these domino things. This is where the throttle is connected. I've taken out the other connectors since I'm not using them. And that's it. I have also didn't mention the power you should run through the Bosch motor. Of course, now the heating, most of the heating that the motor will experience is from the motor itself, and no longer from the controller, because the controller also gets quite hot, and after a long ride it does get hot, the whole thing. So now I've limited the phase amps, and I've also limited the amps to the controller anyway, to I think 800 watts, and you can also go to 1000 watts. It will not be, you know, very harmful to the motor, except, I don't know, if you really abuse it, if you don't you know, do your gear changes appropriately, let's say. And yeah, but the maximum the maximum voltage you can run through this is 1000 watt. That's what it runs with originally, I suspect, because when you start it, even though it says that it's a 250 watt vehicle, it's considered like that in Europe, but always at start it does use more than you know, what is called peak power. So it always uses at least 700 watts from what I've read in some forums. You can run it up to 1000 watts, but that would be, you know, shortening the life of the motor a little bit. In any case, talking of wattage, this controller is up to 6000 watts basically, and you know, running just 1000 watts max, that would be, you know, like a sixth of its capacity, and hopefully the controller will not get that hot in, you know, in that case. Yeah, it's a little bit messy when just because I'm just cramming everything in here like that, and putting the battery, which actually holds everything in place. But yeah, that's the setup for now, and hopefully it will be hopefully it was worth it. Alright, so I'd call that a success, and it's way better than a speedbox. The only thing I'm gonna do next is to get rid of this throttle and try to incorporate the torque sensor into the thing, into the controller. But yeah. So just finally, on the topic of the battery I am using, so it is this one. As you can see, it is a 9 bar 36 volts battery. It's 28.7 amp hours. That equals 1033 watt hours. So yeah, it's quite the big battery, and I found it for a really cheap price actually. and it's a great battery, one of the best, because it is encased in a big metallic case. I think it is a 9p 10s, so that's 9 cells in parallel in the 10s, which makes it 36 volts. It's the back side. And the only thing with these 9 watt batteries, because I already bought another one, this was my second one, and then I also found a third one, which I also bought. For some reason, these batteries pop up on the French website, which is like Craigslist. They kind of pop up from time to time. I don't know where the guys who sell them get them from, except for one of the batteries I bought. The guy told me that he just found it in the street. He didn't know how it got there, so he just picked it up and made a quick buck off of it. In any case, I think because from the research I've done on the internet, these kind of batteries are used with some companies of bike rental companies. You know, the bikes that you find outside, just like the scooters. And of course, it makes sense because it's quite a big, heavy battery, and 1 kilowatt hours, which makes it ideal for a bike to be operated like all day. And yeah, you can't use it just as is, because when you test it actually, and it kind of has this indicator, which now I've turned off because I modified it. But before, when you charge it, you have two ways of charging it. So there's a where is it? There's a port right there, barrel type kind of ports, and also this one. So this is for slow charging, and this is for fast charging. In any case, you can't use it just as is, because when you test the voltage, it gives out voltage, especially when you touch the indicator light. But 5 seconds after, it disappears. So the BMS shuts down, and that's because it is only supposed to work with the 9 watt bicycle. So as you see, it has plus and minus in a lot of other pins. It's 7 pins out here, and some of them are like CAN bus. It communicates with the bike's controller, and then it operates. In any case, if you find a battery like this, I really recommend buying it, because it's a big battery in capacity, also very heavy. But the most important thing is that it's really well made. So if you can see that, so what you are looking at is basically the inside of the battery. In this area right here, there was the BMS was sitting there, and if you can notice all these little dents, those were the marks of components on the board. So there was the BMS and some wiring and this cap. And as you can see, you cannot see the cells, because the whole thing is like encased in this stuff. As you can see, it's some kind of potting compound. So it's an advantage and a disadvantage as you will see in the other battery I have, because actually this one was kind of simple to modify, even though I kind of messed it up a bit, because these are the tabs. This is plus and this is minus, and they were a little bit longer than that, and they were attached to the BMS, and the BMS folds on it like that. So while they soldering it, I didn't have a strong enough iron, and I was pulling on it, so I just broke it off. You can notice that. But I was able to kind of dig out this compound and make a little space, and I made these little tabs of nickel strips. I soldered a wire onto them, and I soldered the strips onto the existing strip of the battery itself. So why is this compound so so good? Because once the battery is made in factory, it is filled with this compound. So you never fear water damage to this kind of battery, and I think it will even help, God forbid, if some fire happens, if some fault happens with the battery. It's encased in quite the thick aluminum case, and plus this compound, of course, I imagine there will still be some fire and smoke, but not if you didn't have all of these barriers of protection. In any case, to modify it, you need to take out the original BMS, and I bought from AliExpress this Ant BMS, although there are tons of other manufacturers which you can find all kinds of BMSs. This one, the advantage is that it works up to 16 cells, 16S batteries, and of course it is programmable, and yeah, right now it's working with 10S. And as you can see, these are the balancing wires, and those are like most of the work that you have to do, because the original wires were soldered, were actually in a they were in a connector right there. Then I took out the connector. I had to measure all the voltages and make sure, you have to make a list and note the voltages of the first cell, second cell, etc. And after that, it was just a matter of connecting all the balance wires, the two leads, and that was it. At least because I had a little bit of space, as you can see, I crammed all the I didn't actually I could have, but I just didn't want to shorten them, but I crammed all the extra wiring in here. I made some loops and a ton of glue inside, so to make it as waterproof as possible, because the thing with batteries, especially in frigid temperatures in winter, if you have a space inside, or even this happened to me actually even with a Chinese controller, ebike controller, once the temperatures drop a lot, there's condensation inside inside the unit, inside the battery, or inside the controller, whatever it is, which creates a lot of problems. So, and this, I suspect, is actually the second version of this battery, and the older one is, so the other version of this battery looks like this. So it's encased in plastic instead of this metallic case, but it's well made also. It has this metallic plate on the back and also on this side. It's the same connection system, the same size, because I think they are all used for the same bike. And the slight difference is that it's 27,900 milliamp hours, which makes it slightly less than the other one, and that makes it 1,004 watt hours compared to 1,033. So basically similar. I think they just used different cells, and I think that it is also a 10S 9P battery. In any case, this one, on the other hand, was quite a bitch to open. It was really hard because basically it was made and it was not meant to be opened. Maybe at the end of its life for recycling, but it was not meant to be opened. I mean, it was, the hardest battery I've opened. It was quite hard because there's a lot of screws and a lot of hidden screws. When you take off these plates, there are even more screws. And anyway, I managed to do it once. I am hesitant to start this one again, but at least I know where to look. So this one actually is the one that I told you the guy found it in the street, and he didn't know if it was working or not, because you just had to push this indicator button just a little bit long for it to wake up. And as you can see, I've left it like this at this level of charge for for more than 6 months now, and it's still great. It hasn't lost a drop, of charge. You can even test it. can see 33.5, but that's not the real voltage. And as you can see, I'm now pushing the button, and there it is. So it wakes up for an instant, 36.5 volts, and then it drops back to standby voltage. And as I said, it does not work straight away if you connect it like this from here to an e-bike. It will. I tried it actually. It will power it on, but it will not. It will as soon as you pull out something like 100 watt or 200 watts. I don't know the exact number, but it was running the motor for like an instant or two, and then the battery shuts off. And so as for this one, this is how it looks inside. So this is the first one that I opened. I've found this little fly case, which is a little bit too long for my liking, but it has been useful. So as you can see, I made a little bit of an opening on the corner right here. So this is how the battery looks inside. As you can see, it was encased in all of this, and I did, just handling it, I did manage to take out a lot of it. Yeah, and so that's the original BMS. That's how it looks. That's also how the other one that I did, the metallic one, also looked. And I left it connected for this one. I just wasn't actually ready to do the work, so I just connected basically the battery terminals. So I was running it without a BMS, basically, but I still used the BMS for charging it. Of course, you always need to use the BMS for charging. But for this charging, it's straight from the battery itself. Indeed, it's bypassing. That's the word I was looking for. It's bypassing the BMS. I will put a BMS in here eventually, but for now it's working, and so does. And this one is more fuller than the other one. But contrary to the other one, this one, it always has the appropriate voltage for consumption. And as you can see, that's 39.3. Yeah, so these are basically some of the batteries that I have. I still have a little bit more. And yeah, I mentioned in the beginning of the video that I'm actually planning a trip with this bike, a long distance trip. And I imagine taking these three at least, or at maximum, because I don't think I can take any more, at least not easily on the bike. I believe that I can be doing something like 150 up to 200 kilometers a day with the and according actually to my calculations, which I've already done some with this one, but in combination with the Bosch battery, so that's 1.5 kilowatt hours. And with those 1.5 kilowatt hours, I managed to do in one day, a going and coming back trip of 150 kilometers. So that's almost 100 miles with 1.5 kilowatt hours, and I still had something like 10% in both batteries. So I'm sure I could have still been able to do something like 10 or 30 or 20 kilometers at the least, which to my estimation, that makes it 1.5 kilowatt hours will let you do at least 150 kilometers in one trip. But it always depends on the conditions, the wind, and also the temperature, because just comparing some of my rides that I've done last summer with this battery, but on my second bike, so I only use this one on it. So I've already done the same trip of 120 kilometers in one day, and I've done it without charging, at the place I've been. So it did it just it was the motor started to be weak just as I was arriving home. So but that's in a hot, not really hot, but in a good day, so 25 degrees Celsius outside and stuff like that. But with this exact battery, the exact same bike, did the exact same trip in winter in frigid temperature, something like 0 or 1 degrees Celsius. And I done the go-in trip, and the battery was discharged to something like 20%. So it, just the difference in temperature will change the range very drastically, actually. So yeah, it always depends on wind conditions, health, and all that. But something that people don't mention enough is the ambient temperature. If you are running a battery outside at 0 degrees, which you can do, but it's not really good for the battery for its operation because it's a chemical interaction inside. You can run it, but you can cut the range in at least half, at least in my experience, or at least 40% in my experience. So yeah, that's about batteries. And if you are wondering what I use to charge these batteries, I will also show you. So one of the best chargers that I found works pretty well with batteries is this manual brick, and as you can see, quite heavy, quite good quality, and it's IP67, so waterproof and everything. As you can see, that's the input, that's the output, and it's rated at 150 watts of output at 42 volts, so that coincides exactly with the charging voltage of lithium-ion batteries, 36-volt lithium-ion batteries. And as you can see, the amperage is 3.5 volts amps. So this is what you would consider fast charging for the normal battery, but actually for these ones it's just about enough, because for this one it takes about 5 to 6 hours to charge it fully. And what I actually done with this one, which I use really often because of the metallic case, I can take it anywhere, contrary to this one which has this big case. What I've done is I do, if for example I want to connect it to this charger, I do the fast charging through this one, this discharge connector. But I also kept the wiring for a slow charger, which I put inside here. It is kind of this is kind of in the way, but it still goes in. And when I put it, that charger only has 1.6 amps, so basically something like 100 watts charging. And that one actually takes more than 10 hours or 11 hours to fully charge this one. And depending on my needs, I either use this one for fast charging, and or I use the other one if I wanted to slow charge it. And that's what I actually do most of the time. So in any case, hope that this was useful to you. If you did like it, please push the thumbs up button, it does help. Otherwise you can subscribe to the channel, and enjoy your rides. Until next time, hopefully. This was the Electron Age. Bye.